All right, it's recording.
Okay, today what you're going to do is you're going to review all of the different forms of the quadratic function. If you recall, in 9th grade and last year, when we did Algebra 1 and Algebra 2, what we did was we looked at quadratic functions and we analyzed them and we figured out their vertex. First of all, the shape is a parabola, right? They're up or down. You have to know how to find the vertex, the axis of symmetry, the x-intercepts, the y-intercepts. You guys in depth looked at all of the information that you need to get out of a quadratic function. A quadratic function is a polynomial. It has a degree of 2. The shape of it is a U. It's either a U or it looks like an N. Okay? They're upward or downward. The vertex is going to be either a minimum value or a maximum value. Okay? So all parabolas have their up or down. They always have a vertex and an axis of symmetry. The vertex is going to be a maximum or a minimum. They all have one y-intercept, and they can have either there can be no x-intercepts, like this example. This one doesn't have an x-intercept. There can be 2 x-intercepts, like this one, or there could be 1, like that one. Okay? So, there's 3 different forms of the quadratic formula that you have to know. And each one of them gives us some nice stuff quickly without even doing any math. Each form has a different, yes.
Do we have to memorize these?
Yes, you have to know them. You'll remember them. You'll remember them once we go through them. This is all review, except this x-intercept might be new for you because of the a value, but it's fairly half of its review. But transformation form is the easiest one. In 9th and 10th grade, you guys worked with this form a lot. Another way we explained transformation form last year in Algebra 2, we also called it vertex form. These mean the same thing, vertex form. Another way of saying polynomial form is standard form. You may remember it, standard form. But your book calls this polynomial form. And then x-intercept form is fairly new. And that's self-explanatory. So what we're going to do today is we're going to analyze each of these forms and how to get all the stuff that you need out of them to graph them completely. Sketch a nice complete graph. Okay? Each one of them specializes in something. And then tomorrow what we're going to do is we're going to analyze going from one form to the other and back and forth. So you're going to be able to go from transformation to polynomial, polynomial to x-intercept, x-intercept to and back and forth. Why do you want to be able to go back and forth? So you can get all the things that you need out of the graph. Okay? So let's look at the first example on the back. This is all review, guys. This form, and if you see it abbreviated TF, transformation form, is also called vertex form. There's 2 names for it. But TF is transformation. What you can get out of this form quickly without doing any math is, see this a value? If it's a positive number, it's going up. If it's a negative number, it's going down. Then this is your axis of symmetry. Do you remember this? X equals 3, that's your axis of symmetry. And 3, 2 is your vertex. So there's 3 things I just gave you without even doing any math. It's just knowing what to get out of this when it's in this form. So there's an error here. this is 3 comma, this is an error. See this 5? Put a 2. I had a different equation typed in here before. So, what's so nice about this form is that the vertex is 3, 2. The axis of symmetry is the line x equals 3, and that this is going downward. Those are the only nice things about this form. The rest you'll have to get. So let's look at an example of one, and let's fill in all this and sketch a complete graph. So far, what do we know about? We need all these, there's 8 things we need. Can you tell me anything? It goes up. The A value is 2, so it's going up. Now, if it's going up, what's our vertex? Is it the lowest point? Is it a minimum value
Minimum.
or a maximum?
Minimum.
Min. A lot of people mess this up. If it's up, it's a min. If it's down, it's a max. Does everyone understand that? Okay, so we got two things. Anyone else want to help me out here? Axis of symmetry, what is it? Don't just say 3. Good, x equals 3. What's the vertex? 3, negative 4. Now the domain is all the x values. Is there any number I cannot put into this? No. So the domain for all of them will be all real numbers. Your range, when you sketch the vertex and knowing that it's going up, it's not down, it's up. Okay? So here's our, let's graph our axis of symmetry, x equals 3. I'm sorry for the boxes being so high.
I'm on the side of the curve, walk across.
Yes, is that, watch the cord, you don't trip. Yeah, you could probably just, thank you. Pass these out?
I don't know what it is.
Oh, okay, yes, I got it. Thank you. Okay, so your axis of symmetry is the line x equals 3, and your vertex is 3, negative 4. 1, 2, 3, 4. So now, the sketch of this is going to be, it's going up so that vertex is our lowest. We said it's a minimum. So all of the y values are going to be greater than or equal to this y value, which is negative 4. So the range depends on this y value and the fact that it's a minimum. So it's going to be greater than or equal to negative 4. Did everybody understand that? Your y value will be, depends on this vertex. If it's going up, it's going to be greater than or equal to. But if it were going down, you would say y is less than or equal to negative 4. If it were an upside down parabola. Okay? So, what else do we know about this? How do you find the x and y intercepts? These are all of the important things you need to know. How do you find any x-intercept or any y-intercept? The x-intercept, you always set y equal to 0. And that's with a linear, anything. The x-intercept, you set y equal to 0. So if I put a 0 right here, how do I solve this? How do I solve it? What do I do? I have 2 times x minus 3 squared minus 4. If I set this equal to 0, how do I solve it? Add 4 and divide by 2. Can I do this in one shot? Because I don't have a lot of room. Then what? Square root. We did this in chapter 2. What else? Add 3. Guess what? These are 2 x-intercepts that are not nice numbers. But they're still places where it hits the x-axis. So, where is 3 plus the square root of 2? this is where we're gonna estimate. 3 plus the square root of 2 is, how do you get what that is? You're gonna do on your calculator, 3 plus the square root of 2, and I have it right here. 3 plus the square root of 2 is approximately, this is an exact answer, these are estimated. So, the x-intercept does not always have to be numbers like 1, 2, 3, 4, -1. They can be in between integers. And so 3 plus the square root of 2 is 4.4, approximately 4.4. That's an estimated answer. And 3 minus the square root of 2 is approximately 1.5 or 1.6, we'll just say. So when you sketch those two x-intercepts, it's in between. So where's 1.5 or 1.6 is about there, and where's 3.5? So it's 4.4, which is about there. Now what do I have here? I have 3 dots. 3 is average. I give it a C minus. Where do I want more? What should I do? How do I get more points?
Figure out.
How do I draw a complete nice graph? What kind of numbers should I plug into my equation to see where it hits? Common sense, what numbers,
Your
what
x
x
and y
values
intercept.
do I want? Right here, 1 or 2, or we don't want 3, we want 4 or 5. Now, if you plug 1 in, where are you going to plug 1 in? In here. You're going to do 1 minus 3. What's 1 minus 3? -2. What's -2 squared? 4, right? Then what's 4 times 2? 8. What's 8 minus 4? 4. So over 1, up 1, 2, 3, 4. And what other number could you give me? Is you could go opposite. That axis of symmetry says that if I'm going to go 2 units this way, I'm going to go 2 units that way. Okay, so we have 5 points. What should we always check to see is where it hits the y-axis. Now, how do you find the y-intercept? What do? Any y-intercept is found by setting x equal to 0. So when you plug x equal to 0 right here, what is 0 minus 3? -3. What's -3 squared? 9. What's 9 times 2? 18. What's 18 minus 4? 18 minus 4 is? So 0, 14. That's your y-intercept. Now we're going to be off the page. But where is it? It's, I think this is 12, if I'm not mistaken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So go 2 up here where the A is. And now could we do another point? Yeah, you can go over the same number of units from the axis of symmetry and up to 14. What do we have now? We have a perfect graph. Enough points, and it should be not a V but a U. It's kind. This has a relatively well, it's 2. Your A value is 2, so it's being stretched by a factor of 2. That's why it's going up fast. The bigger that A value is, the skinnier it is. So for homework, you're going to do these two the same way, 1 and 2. Now, don't do them yet. We're going to go on to the next example. This form is called polynomial form, or another way to say this is standard form, but PF is polynomial form. It's stretched out. There are 2 nice things about this form. The A value in the, what's that? what's this number right here?
C value.
It's the C value, but what does the C value give you? The y-intercept. So if A is positive, it's going up. If it's negative, it's going down. And how do you get the C value? How do you get the C value? You plug this number, if you put an x in, 0 in for x, whatever that is gonna be your y-intercept. Okay? So, those are the only two nice things about this form. So let's look at an example of one. What do we know about this? What is the A value? I don't see it. What is it? It's an understood 1. So this is going up. If it's going up, these are kind of tied together. Although they're asking you different questions, they go together. If it's up, our vertex is going to be a minimum value. Okay. We don't know our axis of symmetry. I'll get to that in a second. We don't know the vertex right now. It's not in vertex form. Okay. What's the domain? What did we say the domain is? It's all real numbers. I can't do the range until I get the vertex. How do I get the x-intercepts and the y-intercepts? Well, this is where you have to go back to chapter 2. How do you find the x-intercepts? You plug 0 in here. So you have 1x squared plus 2x plus 3 equals 0. What are the different ways that we can solve this? We have to solve this. And you learn this in chapter 2, 2.2. How about complete the square? Let's complete the square. Let's bring 3 over, because I can't factor this. I don't know what times what is 3 that adds to be 2. So let's add 3, negative 3 to the other side. What's half of 2? 1. 1 squared is 1. We're going to add 1 to both sides. So you get x plus 1 squared equals negative 2. What do you do next? Take the square root, and this is where you go, uh-oh. What do you do with that?
Plus on the.
There are no x-intercepts. There are none. When you have a radical with a negative underneath it, the discriminant here is negative 2. It's not going to work. Okay? You don't have, think of that negative number. There are no x-intercepts. So this would be an example of one that would be like floating up above the x-axis, or sometimes it's like that, but it's not going to hit the x-axis. So there are none. How do you find the y-intercept? This is easy. This is the easiest thing. It's this number right here, so 0, 3. Now, how are we going to find these 3 items? Do you recall this formula? The axis of symmetry is negative b over 2a. So what is the b value? Axis of symmetry is defined as the opposite of b over 2a. Well, the b value is 2, so it's negative 2 over the a value is 1, so 2 times 1. So what's this answer? What's the axis of symmetry? X equals negative 1. So what you're going to do is let's start putting this stuff in. X equals negative 1 is our axis of symmetry. We know that. We know the y-intercept is 0, 3. Let's find the vertex. How do you find the vertex? What do you do? You're going to plug this x value in here. So what is negative 1 squared plus 2 times negative 1? And then plus 3. Well, this is 1 minus 2. You have 1 minus 2 plus 3. What do you get? Negative 1, 2. That's your vertex. Negative 1, 2. What else can you do? I want a complete graph. Can you throw in another point without doing any math? You're going to go across that point, an easy one. And now you only have 3 points here. What if I want 5, minimum of 5? What would I do now to find some more? What would I do? What would I plug into? I have a T-chart here for you.
1 and -3.
I would plug in a 1. I would use a 1. And let's do the math here. What's 1 squared? And what's 2 times 1? So you have 1 plus 2 plus 3. What is that? When x is 1, what's y?
6.
6. 3, 4, 5, 6. Can you just put another point in without doing any math?
Yeah.
Yeah, it's on the opposite side.
Parabolas are symmetrical, so if I'm going 2 units this way, I can go 2 units that way. If I wanted another point, what number would I plug in? I'd put a 2 in, if I wanted to. And I could do 2 squared, which is 4, 2 times 2, which is 4, and plus 3. So that gives you 11, so 211. And I can go 11 this way. And there, we have a nice graph. There's one thing on my chart that I didn't finish. What is it? Your range. How do you find the range? Remember I said it's related to this y value. Your y values are, because it's going up, it's greater than or equal to this number right there. Okay. Now, tomorrow, what we're gonna concentrate on is how do you go from polynomial form to vertex form? But I bet you could figure this out. How would you change this to vertex form? What did we say the vertex is? What is the vertex for this problem? -1, 2. So here is vertex form. It's the a value, x minus h squared plus k. So how do you go from this form to this form? All you have to do, you need your a value, which is 1. And you're going to do the opposite of h, that's your h value, so it's plus 1 squared, and then your k value is 2. So we just went from polynomial form to vertex form. Now, how would you go to x-intercept form? Well, since there are no x-intercepts, you can't put this one in x-intercept form. So that's what we're going to talk about tomorrow. I thought I'd give you a sneak preview of what we're doing now. Okay, and then go to the last page. Here's the x-intercept form. There's 2 nice things about this one. The a value, that tells you if it's up or down. Same scenario. And then you have your x-intercepts. So when you set each of these equal to 0, you get 3, 0, and -5, 0. They're the opposites of these numbers. Always the opposites. So those are the x-intercepts. That's what's nice about this. So how would you convert any of them to x-intercept form? You need the x-intercepts and the a value, and then you're set. So let's do this one right here. Here's an example. What do we know about it? What's this negative telling us? That it's what?
Down.
That it's going down. If it's going down, is our vertex a max or a min?
Max.
It's a max. Okay? What else do we know about it? So we've got 2 points so far. What else do we know? X-intercepts are what? 4, 0, and -2, 0. Excellent. So 4, 0, and -2, 0. We can plot those points. 1, 2, 3, 4, 0, and -2, 0. Now, does anyone think they know what the axis of symmetry is? It's right in the middle. It's x equals 1. and I'm gonna show you, that's one way you could have gotten this answer, x equals 1. Splitting this right in the middle, 3 units each way. Now, how would you find the vertex then? You know that the vertex lies right on this line. What would you do with, we have to do something with 1. What do you think you do with 1?
Plug it in.
Plug it in, thank you. So it's -1/2 times, you're gonna do 1 minus 3, what's 1 minus, I'm sorry, 1 minus 4 is -3, and then what's 1 plus 2? So what is the vertex?
4.5.
What is it?
4.5.
4.5. It's 1 comma 4.5. So you can go over 1, 1, 2, 3, 4.5, right there. Okay, now, help me out here, what's the domain? We can do the domain and the range right now. Domain is always all real numbers. How do we do the range? If it's going down, and our vertex is 1 comma 4.5, what's our range?
Y is greater than or less than 1.5.
Greater than or less than? Is it less than?
By the way,
It's gonna be less than or equal to 4.5, because it's going down. How do you find the y-intercept? What do? You set x equal to 0. If you put a 0 here and a 0 here, you get -1/2 times -4 times 2. So that's -8. What's half of -8? -1/2 times -8 is 4. So 0.4 is your y-intercept. So can we put a point opposite that? Absolutely, because of the axis of symmetry. What would you do at this point? I want
Just graph it.
5 points, I do have 5, but could I make my graph better? How would you make yours better? What would you plug in? Someone tell me.
-3 or 5.
You could do -3 or 5, and those two numbers will give you the same y value. What other number could I have done? Right here, what's that number? In between here and here. About -1. That's a good one. That's gonna tell me how to connect these two and these two. So let's try -1. If you plug -1 here and here, you get, this is gonna give you, we have -1/2 times, we have -5, and we have a 1 here. So this is gonna be 5/2, which is 2.5. We go 2.5 this way, and then we can go this way and go 2.5. That's a nice graph. Now, like Lexi said, you can plug in -3 and do that, but we're just gonna stop here and just connect the dots. Like that. So, what would you do if I asked you to convert this to polynomial form? What would you do?
Multiply.
Multiply what?
Foil.
Foil. I would foil this. How do you foil x minus 4 times x plus 2? How do you foil it? X squared, can you do it in your head fast? X times x is x squared. If you do these two, what do you get? An atom. -2x and then -8. What do you do with that?
Divide by 2.
You have to distribute a -1/2. So -1/2 squared. What's -1/2 times -2? 1. And what's -1/2 times -8 is 4. So guess what? We just went from x-intercept form to polynomial form. What was so good about polynomial form? What's this right here? The y-intercept. Did we get the right y-intercept doing it a different way? Yes. So you should start to see connections. It's like it's these different connections between each form. Now, what if I wanted to go from this form, what if I wanted the vertex? What would I do now, maybe? Negative b over 2a. So you would do negative 1 over 2 times negative 1/2. That's negative 1, so you get negative 1 over negative 1, which is 1. Isn't that what we said? The vertex is, the axis of symmetry is 1, and we found it that way. How would you find the vertex? Plug 1 in here. 1 squared multiplied by negative 1/2, 1 times 1, add it all up, and you'll get 4.5. Yes?
I thought for standard form you can have fractions.
Yeah. You can.
You can.
Yeah. You're talking about, oh, you're talking about standard form of a line. You're talking about, she's talking about this, if you have. Like that, and we got rid of the 2, you did 2.
Oh, yeah.
This is, yeah, that's something different.
Okay.
Yeah. What that 1/2 tells you, not the negative, but the 1/2 says it's a vertical compression by 1/2. Your graph is wider. Okay? So for homework, you're gonna do these. All of these ones that I left for you. You have 6 problems for homework. I want nice graphs. So tomorrow, we're gonna concentrate on going from one form to the other. There's something you're gonna have to do tomorrow, and that's complete the square. Remember that, completing the square? We're gonna have to work on that tomorrow, a little bit. So for the rest of the time, work on these 6 problems. And you're done. Teddy, can you turn the?
Yeah.
Thank you.